Happy day and welcome. I'm going to make this as simple as possible. This is our simple calorimeter experiment. Okay, so I can either use this simple calorimeter, it's just a fancier simple calorimeter, or I can use this simple calorimeter, which is simply two styrofoam cups with like the one cut off and a thermometer. This is the one that I'm actually going to choose to use today. Again, it doesn't really make that much of a difference. I kind of feel like this one insulates a little bit better and we typically get better results from it. So there is an entire procedure that you can follow, but what I'm basically going to do is just explain a little bit of what I have going on here. That way you can get a better understanding instead of sometimes people really run through a procedure, but they don't really have a good understanding of what they're doing. So I want to make sure that that's the case, okay? So what I have done already is I have a test tube, and it's one of these humongous test tubes here. And so I did weigh that empty test tube, and I got a mass of 42.83 grams. And then I also weighed a test tube, and I put some of this mystery metal. So there are, I just grabbed a couple of these, but there are a couple of different mystery metals. And so this one in here, these are like thicker, heavier, more dense particles. And then I grabbed one of these right here where it kind of has like a coppery looking color, okay? And so this is the one that I actually decided to put in. It kind of looks like little tiny pellets, kind of is what this particular metal looks like. Okay, now, I want you to understand that this is going to be our big beaker of water. The only use for this is actually to heat up the metal, okay? So what I could have done is use something like an oven to get it up to an even higher temperature. So the highest really that the temperature is going to get is whatever the water's boiling at, okay? So we know it's going to be around 100 degrees Celsius, but we're not at exactly sea level here. So the boiling temperature, and our thermometers are unfortunately not mercury-based, they're alcohol-based, so they're not really, I would say, calibrated as well as those mercury thermometers may be, where they're a little bit more dangerous, a lot more dangerous, but you get better results with them. Okay, so I also put this on the balance, so I hit re-zero, and then I put the test tube, and I ended up getting 115.3 grams. Now, what can we do with those two numbers? Well, obviously, if we subtract them, we can get just the mass of the metal inside of there. So just keeping that in mind. Okay. I'm also going to get the boiling water temperature in just a second here. So what I'm going to do is I'm going to clamp this, and that way I'm not just holding it with my hands. And so I'm just going to simply clamp it, and then I'm going to put this right into, and it's not completely bubbling just yet, but I can still just keep it in here and get that going so that it can get the same temperature, okay, as the boiling water. So it'll eventually come to a boil here. Okay, now what else do I have? Well, inside of my calorimeter, so let me go back to this real quick again. So what I'm trying to do is I'm simply trying to get the metal to be the same temperature as the water, okay? So again, I could have put this in an oven and maybe gotten a different temperature, but this seems to be a nice way because I don't know what the temperature is exactly in our chemical oven. It's an old school one, so it doesn't actually give me a reading. So instead, I'm going to use the boiling water. So what I'm assuming is this is not the actual water that I'm using in my calorimeter. I want to make sure you understand this. This is very important, okay? So people will mix this up. And so they just are kind of like going through and just trying to answer the questions according to what they're seeing, and they're not really thinking about it. So I want to make sure that you're thinking about this. This, again, is not the original temperature of the water. What we're talking about are the calorimeter. What we're talking about is this is the original temperature of the metal, okay? So even though it's the water temperature that I'm recording, I'm not necessarily recording the metal. So what I do have here that's going to be going into my calorimeter is I did add a little ice cube into here, and so just so that I could cool this water down just a touch, and so I am going to put this in, and I do want to know the exact mass of water that's going in here. And so what I was hoping for was that it would be about 75 milliliters. Now, yes, I'm saying mass. I'm going to assume that the density of water is 1 gram for every 1 milliliter. So I'm at about 74 right now. So let's get it, yep, right there at the meniscus. So what I have is 75 milliliters of this cold water. Now, it is going to warm up a little bit, so I don't want to record the actual temperature until I've given it a second to really settle. Plus, the styrofoam may have a little bit of an effect on it, so I'm just going to give it some time, and I really want to know what the temperature is just before I add the substance in, okay? So right now, it's reading that it's around something like 12 degrees Celsius right now, so I'm just going to cap this. I'm going to put my thermometer right through this tiny little hole in the top here, and that way I can still get a reading. I can still get a reading on this with this being capped, okay? And so that's going right there. Let's give this a second to come to a temperature where it's actually boiling. So I'm around 95 degrees, and we'll come right back. Okay, so this has been in here for quite a while now. I'm taking a look to see what the temperature says. Now, again, this is a little bit off. There are going to be some errors, but that's okay. So this is actually reading 102.1. 102.1. Now, don't forget, it's 102. Oh, I'm sorry. 102.1. That's perfect. 0.1 degrees Celsius. Now remember again, even though I'm calling that my boiling water temperature, that's not really the water's temperature, that's the metal's temperature. So it's been in here for a while, so my assumption is that it's taken on that temperature, okay? Now my water inside of my calorimeter, so I put the 75 mils inside of here. Ooh, this is exactly 10.00, wow. Okay, it's exactly 10.00 degrees Celsius, so this is 10.00 degrees Celsius. So let me make sure, you always want to go one beyond. So if it's at 10.0, it's 10.00. So like this is 102.10 actually, degrees Celsius. Okay, so we want to make sure we get our sig figs right on here. Okay, so now this is kind of the hard part. Oh, it's going up a little bit, but that's okay. All right. So it's not going to be exact anyway, since this is all experimental. Okay, this is not theoretical. This is all experimental. So what I'm going to do now is I'm going to, as soon as I lift this out, I am going to dump it right into this calorimeter right here. So I want to make sure that it's in here, and then as soon as I'm ready to go, I'm just going to lift this, and actually it's going to take me a second to put it in, okay? It's going to take me a second just because there's only one of me here. But what I have is I have this piece of wood just in case some of the metal gets stuck on the bottom there. So I have this piece of wood just to help kind of knock it in, and there it goes, in it went. I'm going to cap this, and then I'm going to give it a nice little stir here, and let's check to see what happens to the temperature. Okay, so I told you it was exactly 10 degrees, and you can see that it's definitely rising. It's closer to the 20 mark here. Let's give it a little bit of a nice mix just to make sure that we've got an equilibrium between these two. So let's mix, mix, mix. What I'm looking for is I'm looking for the biggest temperature change. I'm looking for the highest temperature change. Now, I did try to cap it as soon as I could, but the truth of the matter is it's not going to cap very quickly, okay? It's very difficult to be able to get it to cap quickly. Okay, so it looks like I'm at 18 point, I'm going to say 90. I'm sorry, I'm going to say 18.99. Yeah, I'm like really close to 19.0 degrees. Okay, so I'm going to say 18.99, and it doesn't look like it's going up anymore. It's pretty much just sitting right there. It didn't really hit that 19.0 mark. It was right there. So let's say 18.99 degrees Celsius. So that's supposed to be degrees Celsius on there. Okay, and really that's it. And we also want to make sure that we know how much water, what the mass was of the water inside of the calorimeter. So the mass, which is, I know I did volume, but again, I'm assuming that the density of water is 1 gram for every mil. So the mass of water in my calorimeter is 75.0 grams. We're going to call that 75.0 grams. That's it. So now, using this information, we would end up calculating, and I'll have this typed up for you, so depending on which mystery metal you have, yours might be a little bit different. And then what we'll do is we'll check to see how close we came to the actual value, and then possibly be able to calculate a percent error. Okay, now let me explain this real quick. You would use percent yield if you are trying to produce a particular product, but you use error if you want to check to see, well, this is a mystery metal, and I'm assuming that it's a particular type that's on, some list, and so you compare it to the one that you think it is, okay? All right, and that's the Mystery Metal Lab. Happy day, everyone.